grade 11s, in CAM activity 3, things are becoming a lot more exciting. We are looking at a cam shaft and follower. Now remember, the cam shaft is the inside part of the circle here, where everything is rotating around. So both camshaft and follower detail of an industrial cam with follower shown at its lowest position. The minimum cam radius is 15 millimeters. So what I need to explain to you is that we have a cam follower here and we have a cam shaft, which I'm going to highlight, which is the inside circle. The outside circle here is your minimum radius, right? And that minimum radius has a dimension of 15 radius. Alright, please make sure of that. The inside cam shaft is diameter 20. You have to make sure that you understand the difference between diameter and radius. So what I'm going to do, I'm going to take this information and I'm going to redraw that information, and it states here in my instruction, draw to scale 1:1 a displacement graph with a scale of 30 equal to 8 millimeters and the follower displacement of scale 1:1 for the given motion. That's very important. So I'm going to project and draw this in this area over here, and then from there I'm going to do my cam displacement diagram. Let's do that first. I have now drawn my cam shaft in the middle of 20 diameter using my circle template, and then from here to there is going to be 15 radius for my minimum radius, which I have here as the second circle. In this particular activity there is no dimensions given to the cam follower, so I've just basically used my own dimensions. I've made that 8 millimeters, where I have 4 on this side and 4 on that side of my center, and I made this any specific length. Alright, so now I'm going to draw my cam displacement diagram from this bottom point of my cam follower, and I project it this way, create a ending line, and use the scale here of 30 degrees equals to 8 millimeters, and there should be 12 8 millimeter spacings, which I will draw my lines up. Let's do that quickly. where I have drawn my construction of my cam displacement diagram, I'm going to go to my specifications for the movement right here, looking at my bulleted points, and I'm going to start at the top, that the cam shaft rotates clockwise in a uniform direction. So clockwise is going to be like that there. And of course my labeling later on will go anti-clockwise. So I'm going to follow my bulleted points here, you follow that, and I'm going to complete my cam displacement diagram. The cam displacement diagram according to the specifications, where it rises by 14 and a further 14, and then it dwells, and then it rises another 26 until it reaches the top. It then descends from there by 18, and then it dwells for 30, and then it descends another 18, and then it dwells for 30, and then it returns to its origin at 360, which is also 0 degrees. I'm now going to take this information and convert it to rotary motion. I need to set up my construction of my rotary motion for the cam displacement diagram to be transferred from linear to rotary. Let's do that now. Right, learners, I've set up the construction. I'm going to use the respective points of intersection here to be transferred onto the respective points which I have here on my rotary motion to be able to form my cam profile. Let's do that now. once I've concluded my cam profile, which I have drawn from my uniform cam displacement diagram, I've also included my center lines, which are two very important lines in my cam displacement graph and profile, which basically would be horizontal and vertical. Please add that as it has value in your assessment. I hope you enjoy it.